Good morning, students. This is Dr. Kasturi from Wales. Today we are going to see the subject software engineering. Let us get into the subject. Today we are going to see about the top block software design. In that we are going to see the topics flow-oriented modeling, design process and concepts, and then design model. In the previous units, we saw UML models, what are users and actors, who are all actors, what are use cases, and then we saw about data modeling concepts, activity diagrams, class-based modeling, etc. So now in this unit, we are going to cover flow-oriented modeling, design process and concepts, design model. Let us get into the topics. Okay, what is the main objective of this unit? This unit explains about flow-oriented modeling and various design techniques. It also describes about DFD. What is DFD? Is data flow diagrams and sequence diagrams. First, we are going to see flow-oriented modeling. What is that? The flow-oriented modeling represents how data objects are transformed as they move through the system. Okay, how the data objects are transformed as they move through the system. Okay, derived from structured analysis, flow models use a data flow diagram, a modeling notation that depicts how input is transformed into output as data objects move through the system. A flow-oriented model depicts how the input is transformed to output. For the stages from the input to the output, there will be several stages between input and output transformation. Therefore, that will be depicted using the data-oriented modeling of the data objects. Okay. Each software function that transforms data is described by a process specification or narrative. In addition to data flow, this modeling elements also depicts control flow, flow of control, from where to where the control is flowing. Okay. Then the flow-oriented modeling is perceived as an outdated technique by some software engineers, but it continues to be one of the most widely used requirements analysis notations in use today. Okay. Then continuation of flow-oriented modeling. Okay, flow-oriented modeling focuses on structured analysis and design, follows a top-to-down methodology, and uses a graphical technique depicting information flows and the transformations that are applied as data moves from input to output. Therefore, they follow the technique of transformations that are applied as data moves from input to output. The modeling tools that are used to build a data flow oriented model includes context diagrams, data flow diagrams usually called as DFD, entity relationship diagrams called as ER diagrams, control flow diagrams, state transition diagrams, data dictionary, process specification, and control specification. These are all comes under the flow oriented modeling. Okay. Although the data flow diagram DFD and related diagrams and information are not a formal part of UML. What is UML? Is Unified Modeling Language. Okay, they are, although they are not the formal part of UML, they can be used to complement UML diagrams and provide additional insight into the system requirements and flow. Okay, therefore the data flow diagram may be like this. DFD level 0, it will be the basic, it will give the generic idea of a software. And then DFD level 1 means it will be some specific. DFD level 2 is more specific. Level 3 it goes on from higher level to the generic to the, from abstraction to the specific level. We can have DFDs start from level 0 to DFD level N. Okay. The flow-oriented modeling takes an input, process, output view of a system. Definitely input, without any process, there will be no output. Therefore, input, process will be having n number of steps. Input, process, output, view of a system. Okay. That is, data objects flow into a software are transformed by processing elements, and the resultant data objects flow out of the software. That is from input to the output transformations. Right. Okay. After flow-oriented modeling, we are going to see the sequence diagram. Okay, what is that sequence diagram? A sequence diagram simply depicts interaction between objects in a sequential order, one after the other. It will be in the sequential order. The purpose of a sequence diagram in UML is to visualize the sequence of a message flow in the system. Therefore, we use sequence diagram in UML to visualize the sequence of message flow in the system, from where to where the message is flowing. We are going to see the order. Okay. The sequence diagram shows the interaction between two lifelines as a time-ordered sequence of events. The sequence is mainly based upon the time. Okay, therefore, what is a lifeline? Is a system taking part during the execution of a system. For sequence diagram shows an implementation of a scenario in the system. Okay, therefore, lifeline is a that takes part during the execution of a time. Therefore, in sequence diagram, lifeline is represented as a vertical bar, and actually what the sequence diagram comprises of, it deals with the interaction between two lifelines. Okay, therefore lifeline is represented by a vertical bar. Okay, message flow between two or more objects is represented using vertical dotted line. Okay, extends across the bottom of the picture. Therefore, vertical bar is represented for lifeline. Vertical dotted line is represented for message flow between two or more objects. And then in sequence diagram, different types of messages and operators are used, can use that. In the sequence diagram, iteration and branching are also used. Looping and decision making are also used. Okay. A small example we are going to see. Okay. This is a small example for the sequence diagram, message passing. Okay, see here we have three lifelines, lifeline 1, lifeline 2, and lifeline 3. Okay, therefore just we are passing the message. One is message, okay, creating a message. We can also give the self message. And 3, what is that? In response to the first message, the reply message was given. And the 4th is the asynchronous message. Yes, for example, first one you can for example, what is asynchronous message? Yes, there is no need both the participants should be live at time. In a telephone call, both the participants will be in live, in video call or whatever call, two persons will be talking. Okay, it will be in live. But in asynchronous messaging like mail, chat messages, both the participant can view or see the message or reply the message whenever they want. There is no need that both the participants should be in live at the same time. That is asynchronous message. Okay, therefore, lifeline 1, from here to here, the message is passed. Same way, from here to here, the message is replied. You can also give the self message. These are the lifelines. Okay, sequence. From this is the first sequence, and this is the second sequence. And see here, first sequence. Okay, second self message is also possible. And third sequence, reply message. And fourth one is asynchronous communication. Means what? Does not require both the parties to be present and speaking at the same time. That is, for example, email, chat, WhatsApp message, and all. Okay. So this is a simple diagram depicting the sequence diagram. Okay. Okay, various messages. See here, this contains various messages here. Okay, self message can be done. The messaging from one person to another. Okay, reply message and asynchronous. We can do synchronous messaging. We can do asynchronous messaging. Okay, and then self message is also done. Before these messages have been depicted using the sequence diagram. Okay, now we are going to see what are the advantages and disadvantages of a sequence diagram. What are the advantages of sequence diagram? Are used to explore any real application or a system. Yes, that's how we saw the message passing. Therefore, we can explore any real application or a system. And next thing is we can represent message flow from one object to another. Yeah, we can see by seeing the diagram itself, we can tell from where to where the message is passed. From which object to which object the message is passed, we can see. And the diagrams are easier to maintain. Yeah. And then easier to generate, can be easily updated according to the changes within a system. Updation is done easily. Same way allows reverse as well as forward engineering. They can backtrack and they can change the diagram. Okay, forward engineering and then the reverse engineering is possible in sequence diagram. What are the disadvantages? Can become complex. One of the disadvantages, sequence diagrams can become complex when too many lifelines are involved in the system. In our previous example, we saw the diagram with 3 lifelines. When there is more lifelines, the sequence diagram become more complex so that we cannot understand it properly. The order of second one is, if the order of message sequence is changed, that incorrect results has produced. Yes, definitely. The sequence diagram, the message order should be followed. If there is any change in the sequence, then means that we'll be getting the incorrect diagram. Therefore, the incorrect results are produced. Each sequence needs to be represented using different message notation, which can be a little complex. Yeah, each sequence needs to be represented using it. The same word cannot be used for many other sequence. Therefore, it will be a bit confusing, but the meaning will be correct. But the same sequence message notation should not be used for all the sequences. Therefore, it will be a complex. The type of message decides the type of sequence inside the diagram. Therefore, we should be very cautious about the message notation, whatever message we are giving. Between the lifeline, what are the communication message we are giving, it is very plays a vital role. Therefore, the type of message decides the type of sequence inside the diagram. Okay, next comes the data flow diagrams. Data flow diagrams, DFD, the model is a perspective of the system that is most readily understood by the users. The flow of information through the system and the activities that process the system. Okay, it provides a graphical representation of the system that aims to be accessible to the computer specialists and non-specialist users. Therefore, what it depicts the flow of data. The models enable software engineers, okay, customers, and the users to work together effectively during the analysis and specification of requirements. Also, this means that our customers are required to understand the modeling techniques and constructs. In data flow modeling, only a limited set of constructs are used and the rules applied are designed to be simple and easy to follow. Therefore, DFD can be easily understood by the customers and also the users. Okay. This rules and constructs apply to all data flow diagrams. That is for each of the different software process activities in which DFDs can be used. Yes, module 1, DFD 0, DFD 1, level 1, DFD level 2, it goes on. Therefore, the DFD levels goes from the abstraction, that is generalization, to the specification. Right, usually the student project also, the students will be using the DFD. They will be giving the DFD level 0 from starting level 0 to level 2 or 3. They will be giving the DFDs for the project. Okay, next it is an example for data flow diagram. Okay, here it deals about the orders, supplies and all. Here we have a supplier. Okay, supplier. And then we are going to see what are the 4 things we have in the DFD, and then we go for the example. Therefore, we should know 4 main symbols in DFD notation. What are they? Processes, data flows, external entities, and data stores. Okay. What are processes? The activities carried out by the system which use and transform information. Processes are rotated as rectangle with 3 parts. Okay, rectangle with 3 parts are processes. And what is data store? Rectangle with 2 parts are data store. That is where information is stored within the system or data store. And they are represented as rectangle with 2 parts. Processes are represented as rectangle with 3 parts. And data flow, it depicts the direction of the flow of data. It's a named arrow. And then what are the external entities are depicted by the oval shape. Okay, see here, what are the external entities here? Supplier is the one external entity here. And what are the processes? Process has three different parts here. That is rectangle with three different parts. This order supplies, collect food requirements, process, okay? And then receive delivery, check for discrepancy, query discrepancy, these, and then make payment. These are all processes. Okay. And what are data store? We are storing the orders. Yeah, that is D to orders. The data store. Why do we say data store? Because it is what rectangle represented in the rectangle format with two parts. Therefore, it is a data store. And then supplier details is a data store. Food details is a data store. And then what? Yeah, supply details, orders, food details. These are all we have three data store here. What are they? Orders, supply details, and food details. And what are the process here? This data flow diagram: order supplies, food requirements, receive delivery, check for discrepancy, and then query discrepancy. These are all the process. And what are data flow? See here, this is data flow. Okay. Therefore, order supplies, orders, check for discrepancy whether the orders are matched, new orders are there, check the delivery. If unmatched orders, they are going for query discrepancy. If the after query has been resolved, it comes to the resolved orders. Those orders are, when the orders are received, okay, and then the received orders are sent to the make payments process. After that, the payment is done to the supplier, and then the supplier will give the invoice. If there is any discrepancy, he will give what discrepancy response will be sent to query discrepancy. After it has been cleared, it will be sent to discrepancy query once again here. Okay. Therefore, if food requirements is sent to collated food requirements here, and then food details from there, weekly food requirements are accessed from this food details data store. Same way, supply from the supplier details, order supply details are sent to the order supply process, and then new orders are sent to the orders data store. Same way, from order supplies, it is sent to the process, it's sent to the external entity supply order, supply query, and then the supplier send external send the query response to the order supplies, and then generate the new order. Okay. After that, supplier will have a delivery. Whatever delivery it is stored in the, it is sent to the process, receive delivery, and check for delivery. If there is any no discrepancy, it was sent to the order. After that, received orders, and then supplier, we will send the payment to the supplier send the invoice. Therefore, here in this example, we have one external entity called supplier. Okay, three data stores, orders, that is data storage, places, data store, orders, supplier details, food details. Okay. And the other remaining these things, three parts, rectangle with three parts, food requirements, order supplies, receive delivery, check for discrepancy, and query discrepancy, everything comes under the process. Okay. And these are what? Delivery. Okay, this is a data flow, which is flow day, delivery is flowed here. And then supply order is flowing from where to where? From order supplies to the external entity supplier. Same way, weekly food requirements from the data store to the food requirement process, likewise. Okay. Therefore, here in the example, we have three main symbols here, processes. Therefore, what are the processes? What? Rectangle with three parts here. Order supplies, make payments are the example here. And what are the data flows? Delivery, supply order, discrepancy query, everything from which is sent from a data store to a process, or a process to external entity like this. What are the information flowed between is called data flow. And then what are the external entities represented with the oval? Here we have only one external entity in this example, that is supplier. Okay, and what are the data stored? Our information is stored within a system. Therefore, we rectangle with two parts are the representation to for data store. Therefore, we have supply details, orders, etc. in the above example. Okay. The diagrams are supplemented by supporting documents. including, okay, these have been are acting as supporting documents, including a data dictionary describing the contents of the data flows and data stores. They'll be maintaining a data dictionary describing the contents of data flows and data store, process definition, which provide detailed descriptions of the processes identified in the data flow diagram. Okay. So in this unit, we summarizes about the flow-oriented modeling and various design techniques. It is also describes about DFD sequence diagram. Therefore, the possible questions that might be asked is explain about the flow-oriented modeling and what is the use of it, and explain DFD data flow diagram and what is sequence diagram and what are the merits and demerits of the sequence diagram. Well, we have in this unit we have seen about the flow-oriented modeling and then the data flow diagram, and then we saw about the sequence diagram and what are the uh, advantage or disadvantage of sequence diagram, also the merits, same thing, merits and demerits of the sequence diagram and the advantages and the disadvantages. Okay, in overall we saw about the flow oriented modeling here. Okay. Okay, flow oriented modeling, sequence diagram. Okay, advantages and disadvantages of it. Data flow diagram we saw elaborately about with the example. And then what are the main components of data flow diagram we saw. And then we came to the end of this unit. Okay, students, thank you. Have a nice day.